We've done a little bit of inverse and direct variation in the beginning of the semester and as well as in algebra. So if you remember that direct variation takes the form of y equals k times x, where k is called the constant of variation. So in direct variation, or to find the k, y divided by x is always constant. And then an inverse variation takes the form of y equals a constant divided by x. Or you could also write it as x times y equals k. So to find your k, you're going to multiply the x and the y. So we have what's called direct variation, which looks like this one. We have inverse variation, which looks like this. And then we have a new kind of variation, which is called joint. Joint is when you have more than one variable that is directly proportional, or more than one variable with direct variation. So here you would read that y is jointly, or y varies jointly with x and z. So we're going to write over here in this box what this would mean over here. So if you have y equals kx squared, this means y varies directly, because the x is on the top, with the square of x. The second one, you have x cubed on the bottom. So this means that y varies inversely with the cube of x. And the third one is z varies jointly with x and y, because there's two variables going on. So you could write it as z varies directly with x and directly with y, or if you just shorthand it, z varies jointly with x and y, means that they're both direct relationships. And for this one, what's going on is you have x and y in the numerator and w in the denominator. So z has to vary jointly with x and y, or you could also write directly with x and y, and inversely with w. And then the last one, z varies directly with x and inversely with the product of w and y. So remember, product means multiply. So, excuse me, is the relationship between the values direct, inverse, or neither? So we did this a little bit in chapter 2 already. So to figure out if it's direct variation, what I do is I see is y divided by x constant. And that's going to give me my k. In inverse variation, I'm going to see if when I multiply x times y, do I get the same number? And that's going to give me my k. Once I figure out what k is, I can either write it in the form y equals kx if it's direct variation, or xy equals k if it's inverse variation. Inverse variation can also be written as this as well. So for letter A, what I'm going to do is first I'm going to divide. Is y divided by x all the same? Is 0.9 divided by 0.8 the same as 1.2 divided by 0.6, or 1.8 divided by 4/10? Is that all the same? No, it's not. So I know it's not direct. Then I checked inverse. So if I multiply these two, am I going to get the same number every time? And yes, you do. You get 0.72, so it's inverse. So the k is 0.72, so you can write it as xy equals k, which is 0.72. And then letter B, first I check direct. So is y divided by x the same for all of these? Is 3.2 the same thing? 3.2 divided by 2 the same as 1.6 divided by 4, the same as 1.1 divided by 6? And it's not. So it's not direct. And if I multiply these two, do I get the same? So this is 6.4, this is 6.4, but this is 6.6, so it's not inverse either. So it's neither direct nor inverse, so it's going to be neither. And then the last one, first check direct. So when I divide this, and I divide this, and I divide this, do I get the same answer if I divide y by x? So when I divide those, I get 15, so that's my k. So my equation is going to be y equals 15 times x. Because remember, direct variation is y equals k times x, and k is 15. Okay, next one. Suppose that x and y vary inversely. So let's make an equation out of that. So if x and y vary inversely, you can write xy equals k, or you can write y equals k divided by x. So I'm going to keep xy equals k. So when x is 0.3, y is 1.4. This information right here is going to help me find my k. So I'm going to do k equals 0.3 times 1.4. So 0.3 times 1.4 is 0.42. So that's my k. So I need to write a function that models the inverse variation. So your function needs to have a constant in it. So my function is going to be xy equals 0.42. So don't just leave it like this. Make sure you actually figure out what k is. Heart rates and lifespans of most mammals are inversely related. So we're gonna write heart rate and lifespan. We'll let this be h and we'll let this be l. So if they're inversely related, so that means that heart rate times lifespan equals some constant of variation k. So to figure out the k, I have to multiply these. So in real life, you're not going to have this 100% inversely related or directly related or direct variation relationship. So if I multiply 634 times 3, I get 1902. And then if I multiply 158 times 12, I get 1896. And if I multiply 76 times 25, I get 1900. And if I multiply 63 times 30, I get 1890. So if you're looking at this, probably the best indication of what's going on here is your k is going to be about 1900. So I'm going to write, my equation is going to be heart rate times lifespan equals 1900. Part B, use your model, so here's our model, to estimate the lifespan of a cat with a heart rate of 126 beats per minute. So heart rate is 126 times lifespan, we don't know, equals 1900. So I do 1900 divided by 126 is about 15 years.